Hi future doctors, welcome to the next class. In dual nature of matter, we have given photoelectric equation, isn't it? So kinetic energy or maximum kinetic energy is going to be h mu minus h mu naught threshold frequency. So incident energy minus work function. So like this hc by lambda minus hc by lambda naught. Like this we have given the equations. Now in this, E is incident energy of the light or photon. What is the formula? H mu or hc by lambda. So whenever you are calculating energy units, you will get in joules. But sometimes in electron volts also you are going to get. While solving the problems, how we have to use this equation. They will give particular wavelength, let us assume 4000 angstroms. Otherwise 400 nanometers. Like this they are going to give. At the time, what is the incident energy, they will ask. So incident energy E is going to be, H is 6.67 into 10 power minus 34. C is 3 into 10 power 8 divided by, so lambda, if you are substituting in angstroms or nanometers, that is going to be very important. Now first we are doing 4000 angstroms. Angstroms means 10 power minus 10. So whenever you are taking this one in angstroms, your answer will be coming directly in electron volts. This one you should remember carefully. So after multiplying all this, final value you are going to get 12,375 something. So nearly we can take 12,400. By lambda should be in angstroms, then energy will be in electron volt. So if you didn't take this angstroms, normally if you are dividing, so normally whenever you are going to be dividing, so you can multiply with this, you will be getting in joules. How you are going to get in joules means, see here, 6.67 into 3, 10 power minus 34 plus 8 divided by 4 into 10 cube into 10 power minus 10. So you can send it to numerator. 6.67 into 3 by 4 into 10 power minus 34 plus 8. This 3 will become minus 3. Minus 10 will become plus 10. So nearly if you are taking 4 will be cancelled in 6. 1 fours are 4. So 2, 26. 4 fours are 16. 6 fours are 24. So 26, 27. Again 6 fours are 24. So 1.66 into 3. 1.66 into 3. So 10 power. So you can see this. So minus 3 plus 7. Minus 3, sorry, plus 10. This is going to be plus 7. 8 plus 7, 15. Minus 34. Minus 34 plus 15. How much? So 14 minus 5. 14 minus 5 is 9. 2 minus 1. 1. So 10 power minus 19. This one you got nearly, correct? This is in joules. Now see here, this joules, if you want to convert into electron volt, what we have to do means 1 joule, 1 EV is equal to 1.6 into 10 power minus 19 joules. 1 joule is equal to 1 EV by 1.6 into 10 power minus 19. You have to write. Therefore, in place of this joule, if you want to write in EV, 1.66 into 3 into 10 power minus 19 by, what you are going to get? 1.6 into 10 power minus 19. So these two will be cancelled. So nearly I am taking, nearly if I am cancelling, we are going to get 3 EV, 3 electron volts. So 3 point something you will get generally, but we did approximately. So why we have done, why we converted into electron volt means, sometimes this work function they will give in electron volts. So many students will subtract directly without changing that one into electron volts. So you do not require this calculation here. So mainly, if you divide directly with angstroms, you are going to get in EV. How you will get, we will see. 12,400 by lambda they gave 4,000 angstroms. 4000 angstroms. Cancel these two. So this is 4 will be cancelled. 3 4s. Already you are getting 3. 3.1. You didn't get that one because of this 1.6, 1.6 we cancel. Now 3.1 because the 0 is there now. 12.4. This 0, 124 by 40. 12.4 by 4. So 3.1 EV, electron volt. So directly if you are taking in angstroms, you will get directly answer in EV. Then you no need to worry about remaining joules or all this. So work function of the cesium. So already we discussed 2.14 EV they will give. So incident light wavelength 4000 angstroms they give. Then what is the kinetic energy of the emitted electron? So K maximum is equal to E minus phi naught. E is Hc by lambda minus phi naught. Now Hc value how much you have to take? 12,400 by lambda you can take directly 4,000. So minus 2.14. So this value you got 3.1 EV. 3.1 minus 2.14 both are in EVs now. So don't forget that 4000 you should write in angstroms. Lambda you should write, wavelength you should write in angstrom. If they give nanometers, you should convert into angstroms. How you will convert means 400 into 10 into 10 power minus 1 into 10 power minus 9 nanometers means minus 1 minus 9 10. So 4000 angstroms. So if they give nanometers, if you add one zero here, it is going to become angstroms. Like that, if you practice, you will be getting idea. Now after subtracting here, so this is 0, 0 minus 4, 10 minus 4, 6. Here 10 minus 1, 9. So 0.96 eV. This is the maximum kinetic energy. How to calculate? So students will face problem while doing calculation for this mainly. For the simple way to solve is this one 12,400 by denominator lambda you should take in angstroms. Now we'll see how that kinetic energy equation graph nature you will be getting. See the graph nature, how it will be coming. K maximum, kinetic energy maximum is equal to H into mu minus mu naught. Otherwise, H mu minus phi naught. Otherwise, Hc by lambda minus phi naught. So, Hc by lambda minus Hc by lambda naught. You can take any equation. Mainly, they will ask nature of the graph by taking this equation. How this equation is going to be represented means K maximum. Graph drawn between kinetic energy and incident frequency. So this is the equation. So K maximum or kinetic energy is equal to H mu minus phi naught or H mu minus H mu naught. If mu is equal to H mu minus H mu naught will write. If mu is less than mu naught, incident frequency is less than threshold frequency, then this value is going to become negative. Kinetic energy cannot be negative. Kinetic energy you are getting negative means that is not possible. That is not possible means no electron will be emitted from metal surface. No photoelectric effect if incident frequency is less than threshold frequency. If incident frequency is equal to mu naught, exactly equal to threshold frequency, at that time kinetic energy is 0. Kinetic energy is 0 means photoelectric effect is taking place because incident energy is equal to work function of the metal surface. Mu equal to mu naught, H mu naught minus H mu naught. Here electron is not moving. One electron will be coming, but it is not moving. It will be there only. So photoelectric effect takes place. If mu is greater than mu naught, then kinetic energy value you will be getting some value that is positive. So H mu is greater than H mu naught. Therefore, photoelectric effect takes place. Now, how the graph will be coming means whenever mu is equal to mu naught some value, kinetic energy is 0. Kinetic energy is going to be minus phi naught. Work function you are going to get. Negative value you are going to get. If frequency is 0, negative value. If incident frequency is 0, kinetic energy is going to be minus phi naught. If incident frequency is less than mu naught, kinetic energy is negative, we will write. Now, further, here this is the frequency 0. Then kinetic energy value negative means this is positive. You will be getting somewhere here. Kinetic energy negative. So, this value is going to give some value where photoelectric effect is going to be taking place. But kinetic energy is 0. Kinetic energy is 0, mu equal to mu naught. So from this equation represents y is equal to mx plus c. So y is equal to mx plus c. C is minus phi naught. X is mu. M is slope of that equation. So y is equal to mx plus c represents straight line but not passing through origin. Therefore, graph will be coming like this, straight line but not passing through origin. If we extend this, it is going to be coming, this is going to be phi naught, work function we are going to call. Otherwise, this frequency we are calling it as mu naught. From this also you are going to get work function because phi naught is going to be h mu naught. Next, what is the slope of this equation? Or sorry, slope of this line. What is the slope of this line means? K maximum is equal to h mu minus phi naught. So K y is equal to mx plus c. C is equal to minus phi naught, that is constant, this one. So x is frequency, on x-axis we have taken. Y-axis K maximum we have taken. Therefore, in place of m, what is there? Planck's constant. So blindly you can remember slope of kinetic energy and frequency, graph on photoelectric effect on metal plate means is equal to Planck's constant. Small h is nothing but Planck's constant. Next, another one they will give like this. Three metal surfaces graphs they will give, kinetic energy and A, B, C. So here total you have three metal surfaces, kinetic energy, frequency graphs. Now which metal is the best metal surface for photoelectric effect, they will ask. Which metal means which is having least work function, that is the best metal surface. I am giving some values here, 2.14, 3.20, 5.14 or 67 EV. Three work functions I give. So from which metal surface we can remove electron very easily means from this, because less energy is there. Therefore, that is the best metal surface. So among all this, which is having least threshold frequency or work function means this one if you are taking. Next, this is for A. Second one, this value is going to be B. Last one, this value is going to be C. So which is the least frequency you can remove means, otherwise you can extend this like this also. Any one you can do, no problem. So if you extend among all these, which is less means this one is going to be less. Therefore, metal surface A is the best metal surface. So on which metal surface we have to incident highest frequency to remove electron, highest work function. C is the highest among these three graphs. So graph is straight line, slope is equal to Planck's constant. So this value is going to give work function for us. This value is going to give threshold frequency for us. 1H, 2H, 3H like this they will give. So you can calculate very easily. So this is the kinetic energy frequency graph. So remaining we will see in our next class.